Okay, so okay, so today we are going to discuss or talk about the still operation of the matrix. Okay, and this is what we are going to talk. It's about the matrix operation. Maybe it's something that's you probably similar with because you knew this in this operation when you were in high school. But today you will find a new kind of operation in matrix. We call it elementary row operation, or we call it in Indonesia operasi baris elementer. Yeah, I'll introduce you today, and please try to understand and try to do exercise as much as you can until you expert. Yeah. Okay, so this is the some review of our previous meeting. In matrix, we have several operation, right? We know the addition, which is it required some condition for the size of the matrix for two matrix to be able to added. So the column of the first matrix should be equal to the row of the second matrix, right? Sorry, I mean in addition, the size of the matrix should be equals, right? The size or the dimension of the matrix should be equal. So suppose that you have first matrix size of m by n, and the second matrix also should m by n. And when you do adding operation, so it's kind of element-wise operation. So each element in first matrix being added to the same elements location in the second matrix. Yeah, so this is the operation for the matrix addition. And in multiplication, we have two kind of multiplication. The first one is the multiplication with scalar, which is the element wise also. Yeah, so if you have a k multiply with a matrix, so each element in the matrix should be add with scalar k. Yeah, so this is the scalar matrix multiplication, and the next is the matrix multiplication. Some conditions should be satisfied in matrix multiplication, which is uh, the size of the regarding to the size of the matrix. Yeah, so the column of the first matrix placed should be equal to the row of the number of row in the second place of the matrix. So let's say we have two matrix that we will multiply A and B, A in the first place and the left side, and B in the right side. So you see that the to be for two matrix being able to multiplication operation. So the size of column in the first matrix should be equal to the row size in the second matrix. Yeah. And you see that if you have A, B, I, J, this is a notation for the entry matrix of the result of multiplication A, B. In entry IJ means, so this is if you have B, yeah, and you do multiplication, so the entry of the matrix, the resultant matrix AB for location IJ will be equal to this one. Yeah, this is come from the I ith column of A dot or times element wise, yeah, each uh, the row, jth row of the second matrix. Yeah, so this is the value for entry ij in matrix AB. Okay, that's the review. And this is just the sum property of addition, matrix addition. Yeah, in matrix addition, it's A, if A plus B, it will be equal to B plus A. So it's called commutative. Yeah, this is commutative property for addition. And the second one is A plus B plus C will be equal to A, you add matrix A plus B and then C. Yeah. And this operation or this property is called uh, association property. Okay, next is if you have a scalar alpha, A and B, capital A and B are matrix. So this one will be equal to A alpha times A plus alpha times B. So it's equal, it's called distributive, scalar distributive properties in the matrix. And next is if you have a scalar, two scalar, alpha and beta, and you have matrix A, it will be equals to A plus alpha times A plus beta times A. So this is the example. So suppose that we have a matrix A here. The size of A is 3 by 2. And we need to determine what is A transpose. Yeah. So A transpose will be equal to the size of A transpose will be A times 3, right? So A size is 3 times 2. The number of column is 2. And the size of A transpose is 2 by 3, which is the number of column in A transpose in and the number of row in A transpose and the number of column in A, they are equal. So it's possible to do this multiplication at point A. And for point B, we have A transpose. Size is 2 times 3, and we have 3 times 2. This is also possible to do for the second multiplication. And you should answer that is it satisfied A transpose equal to A transpose A, right? So to prove or to know the answer for point C, we need to find or determine either A and B, the result from A and B is equal, are equals, okay? So this is for point A, yeah, you see, so we place the A matrix A in the first place and the A transpose in the second place, and we do row column operation, right? Row column element wise operation for each row and column in matrix A and A transpose. So suppose that we want to know what is the size, what is the value for AA transpose in N3111. So this is come from the first row from A times first column in A transpose. Yeah, so this is 2 times 2 plus 1 times 1. So it's equal to 5, right? And the second one, we have 2 times 3 plus 1 times minus 2. So we have 4. And for this entry, we have 2 times minus 1, which is minus 1 plus 1 times 0, so minus 2, right? And so for all you do for one row with one column for this element, and this row to this column for this element, and this row, this column for this element. And we have also for the third row, right? So third row, you operate for each element of A transpose, such that you get all the element for the last row of matrix A transpose. Yeah. And so we are going to do for the point B, which is A transpose A, right? For A transpose A, since A transpose size of the matrix is 2 by 3, right? We have 2 by 3, and for A, we have 3 by 2, such that the resultant matrix is 2 by 2. Of course, if two matrices equal, it has to have, uh, they have to have the same, exactly the same size and the same element, right? Since A and A transpose and A transpose A, they have a different element, so they are not equal. So this one is not satisfied, right? So the answer for point C is not equal or doesn't satisfy. Next is about, this is what we are going to talk today. This, I think this is quite new for you because you haven't got this concept in high school. So it's called elementary row operation in the matrix. Yeah. So elementary row operation, or we can call it ERO. Yeah. In ERO, or in Indonesia, it's called OBE, yeah, operasi baris elementer. So elementary row operation consists only three operation. Yeah. So outside of these three operation, it's not called elementary row operation. So it's exactly three operation. Consists of three operations. The first one is called row interchange atau pertukaran baris. Yeah. So it's like you are swapping two rows in the matrix. Yeah. And the second one is multiplying a row in the matrix by non-zero constant. Yeah. And the third one is you add a multiple of one row to another row. Yeah. Where the multiple is non-zero constant for sure. Yeah. Because if it is zero, it remains the same. Yeah. It doesn't change. I'll show you these three, how to do these three. So suppose that we have matrix A like this. Yeah. It has the first, in the first row, it has 1, 2, 3. In the second row, we have 4, 5, 6, 7, 8, 9 in the third column. And what is the first operation here, which is row interchange? In row interchange, you just baris. Yeah. So you just interchange the row between two rows. So let's say that B1 is for row 1. Yeah, but B in Indonesia it's called baris. That's why it stands for B. Yeah, but you can also use R, it doesn't matter. The important thing here is the index refer to the row in the matrix. Okay. So this notation B1 interchange to B2, it means that in matrix A, you interchange all the entry in row 1 with all entry in row 2, right? So we have, since we have this one, so you change the place. Yeah. 1 change to 4, interchange with 4, 2 interchange with 5, and so forth, 3 and 6. Yeah. Such that after 1 times elementary row operation, which is we use the first kind of row operation, you will have this matrix. Yeah. Matrix is the matrix after one ERO. Yeah, ERO. Okay. So this is the matrix after you do one ERO by interchange the rows. That's why I want you to come on time, because otherwise you will bother other student, because I have to go back to the Gmeet and approve your request, right? So please, next time, try to attend the class on time. Okay, so in this case, you interchange or you exchange row 1 to row 2. Okay. Okay, and other, please have that video. And next is, this is the example of how to do the second row, which is multiplying a row in the matrix by a non-zero constant. So suppose that you have this kind of matrix. This is different matrix with the previous one. The size of the matrix is just 2 by 3. And in this matrix, you want to do one row, right? One operation row, elementary row operation, by multiply a row with a scalar, right? Non-zero scalar. So in this case, the non-zero scalar is half here, and you just multiply row 1 with half. Okay, so since A, we have in the first row, we have 2, 6, 2, 4, 6, right? So after one row, which is multiplying the first row with half by half, so you will get this one, right? So you just take a half of each entry in the first row. Ayan, kayak gitu dong. So you have 1, 2, 3 here. Okay, so this is the example for the 4-second operation of row. Okay, which is you can multiply a row with a non-zero constant. Okay, that's the example for the second operation. Next is the example for the third operation, which is you can add a row, yeah, suatu baris, a row in the matrix with multiply I'll say you can adding a multiple of one row to another row. Yeah. So suppose that you have this one, right? So you add row 2 with half of row 1, right? So you add row 2 or second row with half of first row. Yeah, suppose that you have this kind of matrix and you do row type 3, yeah, which is you add row 2 with half of row 1. So you get, so in this case, row 1 remains, yeah, remains the same. So the thing or the row that change is in the second row. So in the second row, the first one, we have 3, 4, 1, right? And after we add with half row 1, it becomes like this. Yeah. So you see that this is 4, right? 4 plus half of 1. So 3, right? 3 plus half of 1, half of first row, I mean, which is the entry equal to 2, right? So 2 times half is 1, and 1 added to 3, so you get 4, right? So this is 4 times half of 4. Half of 4 is 2, so 2 times 4 is 6. For this case, you have 1 times half of 6. Half of 6 is 3. So 1 plus 3 is 4, right? So this is the matrix after you do 1 time row type of 3. Yeah. So basically you add the second row with half of the first row, or the first row is multiplied by second and then added to second row. Okay. Okay, that's the example or of row. Yeah. So remember that row or elementary row operation consists only 3 kinds. Consists only 3 kinds. Nggak bisa, nggak bisa. Nggak bisa. Okay, so the first one is row interchange. Again, the second one is multiplying a row by non-zero scalar or non-zero constant. And the third one is adding a multiple of one row to another row. Kak, aku lagi ini dong, Kak. Enggak, enggak. Enggak download game-game terus, no. Enggak mau. Hold a second.
Baru tidur, baru bangun, Cok. Oh iya.
Okay, so this is some definition you need to know. Yeah, so definition is really important to communicate during concept explanation. Okay, so the first one is you see that the first and second column, yeah, the first you have this kind of form. It's called extension of the matrix. Yeah, extended form of matrix. Uh, you have this sign means that the left hand side, this is like an equal or similar, right? The left hand side is the matrix before operation and the second one is is the after. Okay, so this is the first and second row. In first and second row here, okay, we have non-zero row, it's called, and you see the third part or the third row in the matrix, all elements are zero, so we call it zero row. Okay, and the number one you see here, we have number one and the first in the first row, and we have number three in the second row. That's called first non-zero element. Yeah, this is non-zero element of the first row. This is non-zero element of the second row. And the number one in the first column also we call pivot or leading one. Yeah, we call it pivot. This is very important. This is a pivot. And the third row, yeah, it's called a zero. It's just a zero row because all elements are zero. Kakak boleh dikecilin nggak, Kak? Kalau nggak, kamu mainnya di sana tuh. Sini mohon dikembalikan. So this is the property of matrix that obtain from elementary row operation. The first one is enriched non-zero row, right? The first non-zero element. You're so late. In easy non-zero row, the first non-zero element is one and it's called pivot, right? In successive row, the leading one in lower row appear farther to the right than leading one in the row above. Yeah, so in the row operations, what is it for? Actually, we will use the operation or elementary row operation to change form of the matrix such that it form what we call echelon matrix. I'll show you or I'll explain it later to you. So if we have a zero row, we always place the zero row in the latest, or at the bottom of the matrix. And in the column contain pivot 1, all other element in that column above the pivot should be 0. Okay. And a matrix we call such a matrix after we do several elementary row operation, such that it form like this. Yeah, this condition 1 to 4. It's called row echelon form. Yeah, row echelon form. Okay, and we can use to change a matrix, just regular matrix, to row echelon form. We can use Gaussian elimination method. So I'll show you how to do Gaussian elimination method. And if you do again the ERO, right? ERO operation, and you reduce the row echelon form such that it satisfies 1 to 4, right? Which is all element in the pivot element 1, pivot 1, all 0. So it's called reduced row echelon. I'll show you the example. So suppose that we want to determine the reduced row echelon form of this matrix. Yeah. So reduce, kalau dalam bahasa Indonesia, matriks echelon baris reduksi ya. So matrix echelon reduksi. So all we always have a pivot, yeah. Pivot element always be in the location, diagonal location, which is the number of row and column are equals. And in reduced row echelon, every element under pivot element should be all 0. So our goal is to do ERO operation such that if we take this element as the pivot, so all element under the pivot, which is 0 and 1, should be 0. Okay, for this one is fine, right? Because it's already 0. Our task is how to reduce or how to make this element to be 0. Okay, how to do that? Remember that ERO only consists 3 kinds. The first one is interchange, a row interchange, right? The second one is we multiply the row with a non-zero scalar or non-zero constant. And the third one is we add a row with other row, right? Multiplied non-zero constant non-zero constant multiplied by a row, and we added to another row, right? So that's the 3 kind of ERO operation. So you have here, for example, you have matrix A here, right? And your goal is, so you choose this element as a pivot, and you want to make all element under pivot to be 0. This one is fine, right? So that your task only to make this 0. To make it 0, you can do this operation, right? You can add this element. Of course, it should be all row here with row 1. So the operation we can do is, so the row 3 is added with or by -2 of row 1. Ya. Baris 3 kita tambahkan dengan -2 baris 1 supaya ininya 0 kan. So we add row 3 with -2 of, or -2 times row 1. You see, -2 times row 1 is, we have -2 here, and this one is -2, right? So we have 2 here, we have 0 here, we have -2 times -1 is 2 here, and we add that result to row 3, right? Such that we have this one is 0, right? This is 0. And the next one is we have -1 plus -2 -1. So -1 plus 2, -1 plus 2 is 1, right? Next is we have 1 plus -2 times 0. -2 times 0 is 0. 0 plus 1 is 1, right? Next is we have 3, right? 3 plus -2 of -1. -2 times -1 is 2. So 2 plus 3 equal to 5. So you see that we change the row 3 here by using this arrow such that we have this result for this third row. Okay. And next is, this one is fine, right? This one is fine. And our next goal is make this element to be pivot element. Yeah, element in the diagonal here we have. So since it's 2, right, you can interchange. Yeah, you can exchange since the row, in the third row we have 1 here, right? And the element in the second column is 1. So you can change the row. Yeah, exchange the row of 2 and 3. So we change the row 2 and 3 such that we get in the second row we have 0, 1, 1, 5, and the third row we have 0, 2, 1, 7. Okay, and after that, since this is pivot, so all element under pivot should be 0. So next job is how to make this 0. So the operation to make it 0, this one should be reduced or should be subtract or should be add by some constant times the first row, right? Okay, next is we add to make it 0, right? This 0. So we add row 3 with -2 times row 2, right? So this one is 2 minus, I mean 2 plus -2 times 1. So you get 0, right? This is what we want. And next is we have 1 plus -2 times 1. -2 times 1 is -2. -2 plus 1 is -1, right? Next is we have 7. 7 plus -2 times 5. -2 times is -10, right? -10 plus 7 is -3. Okay, so we have here, right? This is what we want. And next is the third row. The third row in the third column, this element also should be 1. So since this is -1, so we can do the first arrow, second, right? The first arrow is interchange. The second kind is multiply a row with a non-zero constant, and the third one is add a row with multiplication of a non-constant with another row. Okay, and to make this a pivot, so we will use the second kind of arrow, which is we multiply this row, the third row, with -1. So this is the operation minus row 3. Okay, minus baris ketiga. So minus row 3, we first row and second row remain constant, remain the same. So we just need to change the third row, which is we have -1 minus of -1 is 1, and minus of -3 is 3, right? So this is what we call the row echelon form. Yeah, this part is called row echelon form because all element under one pivot here, all 0. Yeah, until this part is called again row echelon form. Yeah, but what we are going to do, what we need to do is reduce. Yeah, it's not only row echelon form, it's called reduced row echelon form. Reduced row echelon form means that uh, all element should be one. Yeah, okay, and it's not only under pivot that should be one. I mean, should be all should be zero, but above of the pivot also zero. Okay, so in order to do that, from this one we can do backward. Yeah, so what is back forward means that we start from first row and second row and third row, right? For backward means that we start from the bottom, yeah, which is third row here, second row, and first row. Okay, so we start from this pivot, right? Pivot one, and we want to make all element under, or I mean above of this pivot should be zero. Yeah, this is already zero, so it's fine. So what we need to do is to make this part zero. So in order to make this one, which is referred to the second row, to be zero, so you just need to minus, right? You just need to subtract the second row with third row. So that's why, so you add minus of third row to the second row, right? Such that you have 0, 0, I mean 0 minus 0, 0, right? Minus 1 minus 0 is 1. Yeah. So 1 minus 1 is 0. 5 minus 3 is 2. So this is fine. And next is we go to the second column. Yeah. Or second row here. This is a pivot. So what we need to do is to make the element, since this is already 0, right? We want to make the element above the pivot should be 0, which is minus 1 to be 0. To make minus 1 0, right? So you just add, right? You have a pivot here in the second row. So you just add the first row with second row, such that this one will be resulting 0. So this is your zero operation, which is second row plus first row, right? So this one is 1. 1 minus 1 is 0. 0 plus 0, 0. 2 plus minus 1 is 1. Right? And you can look the final result here. This is a pivot, and you see that all element above and under the pivot all 0 here. The pivot in the first row, this is 0. The pivot in the second row, it's all 0. And the pivot in third row, all element above that pivot are 0. And this latest form, right? The last in the last result, it's called reduce row echelon form. Yeah. So this part is called echelon as row echelon form, and this part is called reduce row echelon form. Kalau dari bahasa Indonesia ini disebut matrik echelon, matrik echelon baris. Kalau ini disebut matriks echelon baris tereduksi. Ya. Ini masih matriks echelon baris, kenapa? Karena dia segitiga atas ya. Semua elemen di bawah diagonalnya 0. Itu namanya echelon baris. Echelon baris tereduksi adalah dia seperti matriks identitas. Okay. Okay, so this is the answer. This is the reduced row echelon form of our matrix. Yeah, after you see how many row you do 1, 2, 3, 4, 5, 6. Yeah, so after 6 times row, from matrix A, you get the result. Okay. Okay. You see in this result for each row, you see it only has non-zero element, one non-zero. It has only one non-zero element, one here. And in successive row, the leading one or the pivot one in the lower row appear farther to the right. And in each column contain a pivot one. You see, all the other element in that column, other element rather than one, the pivot, R should be zero. It's called reduced row SLM4. Okay. Okay. That's row or elementary row operation. Next is about the inverse of the matrix. We can use such a we can calculate or we can determine the matrix inverse by using the row. Okay, how to do that? The concept is like this, right? Suppose that you have two kind of your matrix A and B and they are equal to 1. Or you also have B and A times A equal to 1. Yeah. If it's happened, so B is actually the inverse of A and vice versa. A is actually the inverse of B. And so for this one, it's the same thing. So if you have BA, multiplication of two matrices become identity, so they are actually inverse. They are inversion, yeah. So this one, if you have two matrices A and B equal to identity, so A equally is actually B inverse of B, and B is actually inverse of A. One way to determine the inverse of the matrix, we can use the elementary row operation by using this kind of concept. So you can take A, right, and the left hand side, and you have I or identity matrix in the right hand side, and you do several row operation such that you want to change A to be reduce echelon row form or identity matrix. And in the same way, if you do those row that you did, such that also change the form of identity matrix in the right hand side, such that you will get at the end, the right hand side is just the inverse. Yeah, I'll show you how. For example, we have A, of course, for inverse matrix, it should be the square matrix, yeah. If it's not square matrix, so you cannot have the inverse, yeah, concept 3. Okay, so you have A here, and you put A in the left hand side, and the identity matrix in the right hand side. Our goals is we are going to make the left hand side to be identity with several elementary row operation, and of course that operation also will change the form of the right hand side matrix, and at the end, after you get identity at the left hand side, the right hand side it's just the inverse. Okay, the inverse of the given matrix. So suppose that we have here like this, right? So to do that, first is we want to determine the first pivot, right? You can see that in among this row, in the first column, we have element 1 here, right, which is in the second column. So we interchange, we can exchange row 1 and row 2 such that we have 110. And don't forget also you have to interchange or do the same operation for the right hand side of the matrix. So you see all row here, uh, you do the operation or elementary row operation for all element in the specific row. So you interchange or you exchange row 1 and row 2, such that you interchange or you exchange all row 1 and all element in row 2 here. So you will have in the first row, you will have 110, 010, right? 110, 010. And the second column, you will have 3, 2, minus 1, 100. Okay. And we get first pivot here for the first row. And next is how to make this all 0. To make it all 0, so we can add, right? We can add the second row with minus 3 of the first row. That's always be like that. Yeah. So this is the row that we are going to add with another row, right? And you just make a constant adjustment, yeah, such that the result, the operation, the resulting operation of element is 0. So you will have 3. You want to make it 0, so you choose this kind of operation. So 3 should be added with minus 3 of first row. So this is your operation, the operation you choose. And to make the third row or row 3 0, this one is 0. This is to be this to make this 0, minus 2 should be added with 2, right? And 2 come from 2 times 1 here. So to make this 0, all 0, I mean this 0, so minus 2, or we have row 3, right? Baris 3, or row 3 plus 2 times row 1, right? So this is 2 row that you can do to make the element under the first pivot are 0, to be 0. Okay, so this one by doing the first row, you will get this row, this result. And by doing the this row to row 1 plus row 3, you will get this one, right? So this is done for the first column. The second column, so we choose to, you can do the row that can be exchanged, right? So you can also do or multiply the second row with minus 1. Yeah. So next operation is you multiply minus 1 or minus with row 1, row second, such that you will get in the row second, this is minus 1, right? So you will get 1, 1. This one is minus 1. This is from minus 3 to 3 because you multiply by minus. So 0 is 0. Okay. Next is you already have the pivot here. Next is in the third row, also you have a pivot. Already you have a pivot 1 here. So this is done for row operation as a row, row echelon form, right? But what we need to do is to make the left hand side is identity matrix. It means that you still need to make all element other than pivot are 0. Yeah. And after this one, we can do backward, which is we can start from the third column here to make this one is identity, to make this part and this part 0, right? And in order to do that, you see this part is, we want it to be 0. So we want row 2 plus row 3, right? I mean minus, right? Row 2 plus minus 1 times row 3, right? Such that you will have this is 0, this is 1, remains still the same, right? This is 1 minus 1, 1 minus 1 is 0. This is minus 1 minus 0 is minus 1. 3 minus 2 is 1. 0 minus 1 is minus 1, right? It's not identity yet. This is fine for this, right? But for the second column, we still need to make this element 0. In order to do that, so guess what is the operation we can do? So the operation we can do is we subtract or add, yeah, this element or the first row, because we want to change the first row. We add with minus of the second row, right? Such that the operation is like this: the first row plus minus of second row. Okay, and we will have this is the same, right? The thing that the row that change is first row only. Okay, so and the first row we want to add with minus second row. So 1 minus 0 is still 1. 1 minus 1 is 0, right? 0 minus 0 is 0. 0 minus minus 1 is 1, right? 1 minus 1 is 0. 0 minus minus 1 is 1. So you get this one. And you see that on the left hand side, we have identity matrix. Yeah, since it's already be the identity matrix, so you have already the inverse of the matrix in the right hand side. Yeah, so this one is actually inverse of A. Yeah, inverse of this matrix. You can verify is this really inverse by add them, by multiply A and A inverse and verify that the result is identical. Okay, so we can verify A inverse that we obtain from the several arrow operation. So you will get 3, right? 3 times 1 is 3 plus minus 2, 0 is 1. 3 times 0, 3 times 0, 0, 2 times 1, 2, minus 1 times 2, 0. And so you can calculate it yourself, okay? And so for A inverse A, A inverse, this is A inverse, this is A. If you multiply matrix to matrix of these two matrix, you will get also inverse. So it's verified that the resultant matrix from the several arrow we just did before is the inverse of the matrix. Okay? If you have any question, please don't hesitate to ask. Okay, so I'm going to ask a student here, maybe Matthew. Matthew, are
Yes,
you
miss.
there? Okay, so how many arrow we have?
How many years
How many arrow we have?
from
Hmm?
last
In
exercise
elementary
or
row operation, how many operation that's
oh,
allowed to do?
mm, 6? Is it
Huh?
6 and 2
Arrow we have. How many arrow?
or my answer
Arrow
is
is
6?
elementary row operation, right? How many arrow that's allowed in the operation?
6, miss.
Huh? There are. Ah, oh, so sorry. How many? Huh?
Is it use?
Matthew?
Oh, yeah, use. Uh, how much the elementary rows?
Huh?
Is it your question, right? How much the elementary rows that we can count?
I can't really hear you actually. Your voice is very. Maybe another student. Laya, how many kind of elementary row operation that allow to do?
Use. Hello.
Ozaki. Halo Zaki.
Is it three missed?
Zaki bisa lebih besar kan suaranya? Can you speak louder?
There is three, Miss.
Okay, there are three, right? Three kind of operation. Can you
Yeah.
say it?
The first one is interchange.
Interchange apa?
Inter interchange the row.
Interchange the rows, right?
Yeah.
Means that you change for every element of two
Yeah.
rows, between two rows, right? Yeah. The second one is
Yeah. Dikali barisnya dengan konstanta. Apa tuh ya bahasanya?
mengalihkan baris dengan konstanta tidak nol.
Ya.
Yang
Terus
ketiga,
yang ketiga tambah kelipatan baris lain.
menambahkan dengan multiplication of other row.
Other row. Yeah, other row.
Okay. So this is 3 row that's allowed in the Gaussian. Okay. And I want to tell you that this kind of method, right? This kind of step that we do from the given matrix to the row echelon form like this, ya. Ada row echelon form, ada reduce row echelon form, right? Dari sini ke sini itu dinamakan sebagai Gaussian elimination, ya, eliminasi Gauss. Dari sini ke sini, dari yang bentuk identitas itu disebut sebagai Gauss-Jordan elimination. Nah ini ya, ini Gauss elimination itu cuman sampai ke row echelon form atau bentuk echelon baris biasa. Kalau sampai identitas atau reduce row echelon form, itu dinamakan sebagai Gauss-Jordan elimination. Prosedurnya ya. Okay. Yeah, it's just another example. I hope you can do it yourself, yeah. Don't be scared with the decimal we have here. Yeah, the procedure are the same, right? The thing we have here is this is given matrix, and we want to determine what is the inverse. You see that the first step always be find or determine the first pivot, yeah, or leading one. Leading one means in this case, right? We don't have any leading one here, right? In the first column. So you can make it by using, since this is half, right? 0,5 kan half ya, setengah 0,5. Since this is half, so kamu mengalihkan baris pertama dengan sesuatu angka yang menjadikan dia jadi 1 ya. Jadi setengah supaya jadi 1 dikalikan berapa kan? Dikalikan 2 gitu ya. So you add or you multiply the all element in first row by 2, right? Such that you will have This is 1, 1, and minus 1. You have 2 here, right? Since 1 times 2 is 2, 0, 0. Oke, nah setelah itu stepnya kedua, mengenolkan yang ada di bawah pivot. Ini sudah jadi pivot, elemen-elemen yang di bawah kolom harus jadi pivot. Caranya gimana supaya jadi pivot? Ini kan harus ditambah nih 0,5 kan. Supaya ditambah 0,5 dengan acuannya baris pertama, baris pivotnya gimana caranya? Berarti ini harus ditambah setengah. Tambah setengah karena ini 1, jadi baris kedua ditambah setengah baris pertama. Baris kedua ditambah setengah baris pertama. Untuk membuat ini 0. Dan ini implikasinya semua ini harus dioperasikan karena operasi baris. Selanjutnya ini yang 0 kan. Nah, untuk mengenolkan ini gimana? Ini karena isinya 0,25 supaya jadi 0 harus dikurangi 0,25 kan. Dengan acuannya baris pertama. Supaya ini dikurangi 0,25 berarti baris ketiga dikurangi 1/4 baris pertama. Nah, kamu lakukan operasi arrow ini, OBE yang pertama ini untuk menjadikan ini 0, yang ini untuk menjadikan baris ketiga elemen elemen di bawah satu utama di baris ketiga supaya jadi 0. Oke, sehingga kamu punya ini. Nah, ini impact-nya ya. Ini semua kan harus dioperasikan setiap elemen. Ini juga pasti berubah. Oke. Next-nya adalah berarti pivot yang selanjutnya ini sudah 0, kamu lanjut ke yang kedua, ini sudah ada pivotnya kan, tinggal membuat ini 0. Supaya ini jadi 0, acuannya si baris yang ada pivotnya ya. Jangan dengan baris yang lain, karena kalau dengan yang baris lain ini nggak akan jadi 0 lagi, berubah. Kita mau ininya tetap 0. Jadi si yang ini harus dinolkan dengan baris yang ada pivotnya, baris di atasnya ya. Jadi 0,5 dikurangi, berarti kan supaya jadi 0, 0,5 dikurangi setengah baris kedua, atau operasinya adalah baris ketiga. Ya, ini supaya jadi 0. Baris ketiga dikurangi setengah kali baris ke Oke, nah, jadi kamu punya ini. Habis itu, apa namanya? Udah segitu ya. Oke, sehingga kamu punya ini hasilnya ya. Ini kamu bisa lihat di sini. Nah, kamu bisa lihat di sini apa hasil akhirnya ini tidak identitas ya. Sorry. Karena tidak identitas, harusnya kan kalau di identitas di sini 1 ya. Nah, ini tiba-tiba punya baris 0 di kuas kirinya. Nah, kalau nggak bisa dibuat identitas, maka pasti matriks ini tidak punya inverse. Gitu ya. Jadi ini bukan inverse-nya. Jadi matriks ini makanya pertanyaan determine the inverse matrix if it exists ya. If exists ini. Nah, karena kita punya baris 0 di echelon baris reduksinya, maka tidak punya inverse. Oke. Okay, next. This is the properties of matrix inverse. Yeah. So suppose that we have A inverse, and the inverse of A inverse is just A. Okay. So if you have A B inverse, it will be equal to B inverse times A inverse. Okay. So if you have K non-zero constant, yeah, of real number, then K A inverse will be equal to 1 over K times A inverse. Yeah, and it has a consequence, or it implies, then if you have A power n inverse, it will be A inverse power n. For example, so we have A and B here. We want to determine what is AB inverse, right? So AB inverse is just B inverse times A inverse ya. Jadi sebetulnya kamu bisa kalikan dulu A, B-nya, kemudian di-inverse-kan, atau Kamu cari masing-masing inverse dari A dan B, kemudian ini it will be equal to B inverse times A inverse. Okay? So we have this one such that this, right? This is the first way. Okay, and next is you find the inverse of each matrix of each A and B. So for A, we have this is the inverse of A, and for B inverse, we have this matrix. And you see, B inverse A in times A inverse will be equal to this one, which is the same result we have. Okay. So they are equal. Okay, and for the A inverse power 3, yeah, it's also will be equal to the A inverse power 3. A power minus 3 will be equal to A inverse power 3, yeah, which is you find A inverse here and then you add or you multiply 3 times. Yeah, so you have A inverse time A inverse time inverse such that you will get this result. Okay, and if the matrix below, yeah, is n time n matrix, and they all have an inverse. You need to simplify the form. Yeah. So from this part, A B inverse, you will get this is B inverse A inverse, AC inverse, just AC inverse, right? For this part, it's just since we have an inverse here, right? So C inverse inverse is just C. C inverse inverse is just C, right? You will find it as a C here. And this one is D inverse D inverse D inverse. Such that we can simplify this is B inverse A C inverse C D D inverse. This part is just identity. This part is also identity, and this part is also identity, right? So it remains only B inverse, yeah? So this one, we can simplify by using inversion property of the matrix. It equals to B inverse, okay? Next is just exercise. Maybe I can do it, we can do it together. But let me see the time. What time is it? Okay, I still have time. Okay, so let me open Word, Microsoft Word. So number 8. Okay, so this is the matrix we have, right? And determine the row echelon. Row echelon is not reduced, right? So row echelon needs only upper triangle form of this matrix, right? Of A and B. I can do just A maybe, and you can do the same thing for the so we have A here, right? Okay. So this is our matrix, right? The first one is always start from the first column or first row. Find the pivot, right? So this is the pivot, should be the pivot. You see that we don't have any one element here, right? So we can just multiply the first row with half, such that the row 1 half is itu lagi row 1 times half, right? Okay, this is row 1 times half, such that you will get, okay, all element in row 1 multiply with half, so this is 1, right? This is minus half, right? This is 3 seconds, right? 3 seconds. Okay, this is we have here. We have a pivot element here. Okay, and what we are going to do is to make all element under the pivot 0. This is already 0, and our task is how to make this element 0. So this is element of row 3, right? So row 3, right? So we are going to plus, right? We are going to add, yeah, with two times row 1. So this is the operation we choose to make this 0, right? To make this 0, you need to add with 2, right? And 2 can come from 2 times row 1, right? Such that you will get this is minus 1 plus 2 times 1, which is 0, right? This is 1 plus 2 times minus 1, minus half. 2 times minus half is just minus 1. Minus 1 times 1 is 0. And this one is 4, right? Plus 2 times row 1. 2 times row 1 is just 3, right? 3 plus 4 is just 7. Okay, so we're done with first column. Next is finding the pivot in the second column, which is this one, right? And we cannot exchange with the upper row, and we don't have any non-zero element in the next row, in the bottom, in above of this element. So what we can do is just multiply the second row with fourth, 1/4, such that we will have row 2 times a half. Yeah, a half maybe 1/4. Yeah. So we will have this one, the result from the this operation. So this one is this one, right? From 4, we multiply with 1/4, so we have 1, and in this case we have 5/4. Okay. So this is the pivot, right? And next is just a row echelon form, right? Row echelon form means that we already have the result for column 1 and second column, and what we need to do is the next one, right? So this is the pivot, and since this is 7 and it should be 1, right? So we can add row 3, multiply row 3 with 1/7. Yeah, so this is 1/7. Okay, okay, so 1/7. I don't like to put some here. 1/7 times times row 3, right? 1/7 times row 3, such that this is 0, remain 0, right? 0 times any constant should be 0, right? So we have 7 remain here. 7 times 1/7 is just 1. So you see, we have all pivot in every row here, and this is just one pivot 1 or leading 1, and this is just upper triangle matrix. So this is what we call row echelon form. This is row echelon form of the given matrix A. Okay. And so please do the same thing. Yeah. Please determine a row echelon form for matrix B by yourself at home. Okay. Next is determine the reduce. So this is not only row echelon form, but reduce row echelon form. Yeah. Reduce means that uh, we 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 don't need only upper triangle, but it should be identity, right? To make it identity, so we need to make all element above the pivot all zero. So we can start from this and do the backward step, yeah, or the backward procedure. How to do the backward procedure is we start from this. Let me make it green for backward. Okay, we start from the latest column we have here. So we want to make all zero here. To make it zero, how to do that? So we can do two arrows, right? We can do two arrow. Let me make maybe like this, right? To make second row 0, 5, 4, 0, it should be a row 2, right? Row 2. So we add about, we add minus, right? Minus 5 of fourth, right? Minus 5 fourth of row 3, right? And we added to row 1, row 2, right? So we multiply row 3, which is we have pivot here, right? With minus 5 fourth, yeah. And then add to row 2, right? This is to make this element 0. And next is this one. To make it 0, we can do the similar thing. Since this is 3 seconds, so we can add to the rows first row minus 3 half minus 3 seconds of row 3, right? And we add to row 1. Okay. Okay. Ini ngapain kamu datang udah mau selesai juga. Ria. Okay, so we have this one is 0, right? So we do the first operation here. So this part is 0, okay? And this part is, I think, remain the same, right? Since we have row 2 means that 1, right? 1 plus minus 5 fourths times 0. Times 0 always be 0, right? 1 plus 0 is always be 1. 1 plus 0 is always be 1, right? And for the 3 second, we have this operation, right? So this is a 0. And we can also this one, right? Minus 3 second of 0 plus this one is remain this part, right? So it's nothing changed here. And for this part also the same, right? Since we have a 0 here, 0 times minus 3 second is 0. 0 plus 1 is 1. It's still 1. We have done with the latest column. And next is to make it identity, which is the reduce row echelon. We need to make the second, we need to move to the second column, which is make the element above the pivot 1, 0. So this part should be 0, right? In order to make this part 0, we need one arrow operation, I guess. So this one is we have B2. Yeah, we want to add to B2 half of B2, right? Half of B2 plus B1, right? Half of B2 plus B, such that we are going to have okay, this part is this one is nothing changed in this column. In this column we have half of 1, half of 1 is half plus minus half is 0, right? Like this. And it's nothing changed in the first column, such that this is if we observe this the result, the latest result we have here, it's just identity matrix, or it's called reduced row echelon form, right? So this is the reduced row echelon form of given matrix A. Please do it for matrix B. Okay. Okay, next is if the matrix below are n times n matrix and are invertible. Invertible means it has an inverse, yeah. Simplifying the following expression. Okay, so using the property of the matrix, it will be equal to this is C inverse, right, for this part. And we can start from this part, right? Let me make colors on that. Right? This part is just using the property of the inverse. It's just A inverse inverse, right? A inverse inverse is just A times B inverse inverse. B inverse is just B. And this part is, so I'm going to put color green. And for this part, we have a B inverse, right? B inverse, A inverse. Okay. Okay. Times C. Such that we gonna have okay. Nice. We're gonna have this part, right? This is like just identity, right? So we will have C inverse A, B inverse is just identity, and we have A inverse C, right? And any matrix that multiply with identity, it's just that matrix. So we can simplify this part to be C inverse A, right? A times in identity is just A, right? So we will have A inverse and you see in this part we have A inverse, it's just identity. So we have C inverse identity times C. And any matrix that multiply with identity is just that matrix. Yeah. So this is just C C inverse, I mean times C. And C inverse times C is just identity. Right? So this matrix, if we simplify using the inverse property, it's nothing, just identity matrix. So this one equal to identity. Okay, so do you have any question? Anyone have a question? If you don't, I think that's all for today. Please don't forget to try to not try, I mean to please don't forget to do the online quiz. We have two online quiz that have to be done today. Yeah, and I will not make any exceptions, or I will not extend uh, the deadline of the quiz. Yeah, so if somebody requests me to extend, I'll say no. Okay, so please try to do it on time. And also you can do some exercises that we have. Okay, this is a quiz, right? So please do this quiz week 1 and quiz week 2. They are still in Bahasa Indonesia, but doesn't matter. Okay, and okay, you can access this, right? Tugas Subsil 01. Okay, it's open, and you can try the exercise. You can try to do the exercise. Yeah, there are, I think, 5 points or 5 problems there. So please try to solve the exercises. Yeah. Okay, this is just about the matrix operation. And this is about the determinant, which is you haven't studied yet about this. Maybe you can just skip this. Yeah. And the number 3 is about the determinant. You can just skip that too. And this is you haven't. Okay, maybe number 1 and number 5. You can try to solve number 1 and number 5. Okay. If you have any questions, please don't hesitate to ask me. You can reach me even in the group chat, our Telegram. Okay. So if you don't have any question, I think that's all for today. Thank you for your attention. Please do the online quiz on time. Yeah, don't miss that. Thank you very much. Good morning.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.